Alright, in this example problem we have a metal rod here that is rotating about its center, and we're given its mass and its full length is 50 centimeters. At the end of that metal rod there are point masses placed, one with a mass of 0.1 kilograms and one with a mass of 0.2 kilograms. And we want to know what the moment of inertia of the system is. So since we have a metal bar and 2 point masses, we need to add together 3 moment of inertia equations to find the moment of inertia of the system. So the first thing I did was look up the equation for the moment of inertia of a metal rod rotating about its center. That's going to be different than the equation if the metal bar was rotating about one end. So make sure you grab the one where the metal bar is rotating about its center. I'm then going to add in the moment of inertia equation for the 2 point masses. So I'm plugging in, there's a 1/12 up front, there's the 2 kilograms, which is the mass of the bar, and 0.5, which is the length of the bar. Then we have the mass of point mass 1, and then we have to be careful here because remember the r in the point mass equation is the distance between the rotation point and where the mass is located. So since the metal bar is rotating about its center, we have to divide the length of the bar in half to get the distance from the rotation point to where the mass is at. So that's 0.25 meters. So then we plug in the mass of the second point mass, and then that's also 0.25 meters from the rotation point. And so then we get an answer of 6.04 times 10 to the minus 2 kilogram meter squared. So since we're taking a mass times a distance squared, we get units of kilogram meter squared.